All right, so now that we have whole numbers and some of the other objects added together, let's see how we would add fractions. Again, we want to add like units. So these two are now represented, and we don't really have equal parts or units to add them together. So here's what we're going to do. We're going to take our grid of 2/5 and overlay this grid of 1/3 on it. So now look, instead of 5 equal pieces, I have 15 equal pieces. I can do the same here with 1/3. Overlay the 2/5 grid on the 1/3 and then move the pieces because now they will fit. Can you see that? So now we have equal pieces and we can see how many we have when you added them together. Overlaying that grid is same as making equivalent fractions. So you took the 1/3 and overlay that third threes onto the 5, which is same as multiplying numerator denominator by 3, which gave us 15 pieces, and we have 6 of them. The yellow are the 6, that's the 2/5. Here we did the same and we overlaid the 5 on the 3, so that gave us 15 equal pieces here, of which this represented 5 pieces, so total of 11 fifteenths. So 1/3 and 2/5 add up to give you 11 fifteenths. In this case, 1/15 was the common unit. 1/15 was the common unit because then both numbers could be represented out of the same number of pieces, so we can see how many we got. So when you're looking at fractions, for right now, we're saying just overlay them and you have it. Or make equivalent fractions. This is called the common denominator. So when you're doing fractions, just pay attention to this bottom. If they're both out of same number of pieces, then we can add them. All right, let's try that on your own. See what you can do. This is called the strip diagrams when you draw rectangles like that. So draw the strip diagrams and see what we can do. Remember how we overlaid the grid? So try that on your own. Give you a few moments. Pause the video, please. All right, so let's make the grid. If you overlay them, let's see how many pieces we have here. 1, 2, 3, 4, 5, 6 this way and 4 that way. So that will be 24 and 24 here. So this we can rewrite then as 18 24ths, right? 3, 6, 12, 18. So that's 18. And here we have 4, 8, 16, 20. So we have 20 24ths and 18 24ths added together. So again, what? Put them together. Okay, so that is what? 1 whole, right? 1 whole and how many? 14 24ths. 1 whole and 14 24ths. That's how many pieces when you put those together we got. And 1 24th is our unit here. This one tiny little piece here is 1 24th. This is your whole right here. So we have 38 24ths, we have 38 pieces, or 1 whole and 14 24ths. No, we made 24 pieces, but we don't have to. As long as you make common unit, it doesn't matter how much the unit is. So how about this? Would 12 work? I made 12 of each, and I have the same answer then. Can you see that? So watch again. So this is what I started with, 3/4 and 5/6. Okay, I halved, put a half through here, and same thing, make 12 pieces here, and look what we got. Okay, so what's the answer then? We have 1 whole, right? 1 whole and 7, 1, 2, 3, 4, 5, 6, 7 twelfths. So 1 whole and 7 twelfths. So we don't have to make 24 pieces. 12 works just fine, and maybe something else might work. So there are many different smaller units you can make the fraction out of so that we can add. The most important part being that the denominator has to be the same all the way through. That will allow us to add. And then it's just like a whole number addition, isn't it? We have 9 1/12ths. We have 9 copies of 1/12ths and 10 copies of 1/12ths. giving us 19 copies of 1/12. And the 1/12 is this little piece right there, giving us 1 and 7/12 pieces. The previous answer didn't look 7/12, but if you reduced it, it would be the same. We'll work more on how to make this common denominator a little bit later. But for right now, any denominator that works, use it. All right, so try that one on your own. Pause the video here and see how you would draw a strip diagram for it. Have you paused it yet? I'll give you a head start. So here we have 2 whole and 3/4. Here we have 4 wholes and 1 1/3. Right? So 4 wholes and 1/3. And 2 wholes and 3/4. To add them together, then here's my 2 3/4. Here's my 4 wholes, and here's my 1/3. So the whole part is already done. 1, 2, 3, 4, 5, 6. We have 6 wholes. These two to add together, see how you can split them like that, and then move these 3 pieces here. So we have 1 whole and 1/12. So the total will be 7 and 1/12. 1, 2, 3, 4, 5, 6, 7. 7 whole and 1/12, which is the same as doing this process, making equivalent fractions. Add the whole parts first. To add the fractions, we made the bottom to be the common denominator of 12, 24. Any of those would work. We chose 12 when we overlapped the grid. Right now, you want to make sure you can do it pictorially like that, because it's going to help you understand exactly what's happening. So now, extending our pictorial interpretation to this problem, assume that the x is large enough, that is more than 3, to make sure that you can draw this kind of strip diagram for 3 over x plus 2/5. So here we have 3 out of x. Okay, and here I have 2 out of 5. So that's my 2/5. And here I'm going to overlay the grid of this grid on top here so I can see what I have together. Okay, so let's move the 2 strips and let's move these chunks here. So this is what I have total when I add it together. So what is this? In terms of how much space is occupied here, remember, this is x and this is 5. So this is 5x. The whole area is 5x. And out of that 5x, what do we have? We have this little thing here is 1. So we have 15 ones here, right? Because this was 1 and this is 1. So 1 by 1s. And 2 x's. This is 1 times x, 2 x's. So 2 x's, and here we have 15 little pieces. So 15 plus 2x out of 5x. That's what you have here. In other words, 5x was our common denominator. We made equivalent fractions, and then you add like terms. Once you have common denominators, then you're just adding what you have. And remember, the final answer has to be a fraction. So try this for video log.